Good evening, everyone. My name is Prendergast. I'm the CTO of MIMIR Blockchain Solutions. I want to say thank you for coming out, and thank you for letting me have the opportunity to speak in front of all of you today. I'm going to be discussing the scalability considerations around blockchain and what it's going to really take to realize all of these different wonderful ideas that we've been listening to before this point. There's a lot of scalability problems, and the three that you probably are familiar with, the three that you hear quite often are, of course, the transactional throughput of blockchain technology, as well as the block time around blockchain technology, and then finally, the transactional fees associated with using blockchain technology. Within the realm of transactional volume, currently, the Ethereum network is capable of supporting something on the magnitude of 10 transactions per second. This is a pretty small number when we think about things like the Visa processing network that can carry tens of thousands. If we're going to use this technology to realize a payment processing system, we have to overcome this shortcoming. The second one here on the board is block time. Everyone here is, I'm sure, aware of proof of stake versus proof of work, and the fact that we have to actually slow the system down in order to let everyone come to an agreement. This is the shortcoming of proof of work, but it's manifest because of non-finite network latency, or in English, it takes time to get messages around the world. Transactional fees, this is a very big problem because a lot of the applications that are most exciting are microtransactions. Having a 10-cent transactional fee or a 50-cent transactional fee is not concerning if we're spending an immense amount of money. Say we're buying a car or sending a large international transfer. But if we're buying a stick of gum, 10 cents is a non-negligible division of the total price of the asset or the product. The solutions to these problems are diverse. Within the realm of transactional volume, we have the ability to use proof of stake systems. This will decrease the block time, at least on the Ethereum network, potentially to 2 to 3 seconds. This will manifest about a 5 to 10x increase in throughput on that piece of technology. We also have micropayment channels, sharding, and several other technologies, but the only one that we've actually seen at least partially enacted is the micropayment channel, and that would be in the form on the Ethereum network of the micro-rated network, within Bitcoin, of course, the Lightning network. Transactional fees also are solved by microchannels. They allow you to settle state and have secure exchange of value without recording all interactions back to the blockchain. This has an immense potential, and it will substantially increase transactional throughput because you're no longer tied back to the block times, and you no longer have to interact with the actual blockchain for every single transaction. The last two are the scaling considerations that we don't talk about very often, or you don't hear about very often. These are the database size and secure interaction from edge-connected devices. These two graphs speak very much to what this problem is today. The growth of the Ethereum network is exponential in nature. If you can look at what's happening with the top graph, it is a graph of the addresses that exist on the public Ethereum network as a function of time. The line against the bottom of that graph is the number of blockchain clients that exist in the world. This is the secure software that allows you to actually directly interface with the P2P network that makes a blockchain. The bottom graph is a graph of the Ethereum chain size. So essentially the size of that database is a function of time. You can see that we're already on the compressed database to over 50 gigabytes. This means that we can't put this on many embedded devices, and we can't put it on mobile devices, and this is what we interact with on a daily basis in the terms of mobile devices and some of the most promising technologies when we're talking about IoT. These shortcomings are limiting what we're capable of doing, and we have to figure out a way around them. Within the realm of secure interaction, this is actually one of the things that MIMIR is tackling, the company that I work with. We've been looking into how can we get messages out of the blockchain into mobile devices, into edge-connected devices with the same fundamental securities that are afforded by actual interaction with a blockchain node. If we think about how most people are interacting with the blockchain, we can look up and see what the trend is. The vast majority of people are interacting through someone else's software. This is a point of centralization. This is a single point failure within the system, and it fundamentally undermines all of the security associated with disinterested third parties validating transactional information. Or in English, no one's double checking anyone's work if we're just talking to a single person who's giving you information about the blockchain. MIMIR has been building a technology that allows for a device to make a request against the public Ethereum blockchain and to use a proof of stake system that has second parties or third parties validate the information being provided back to the end user. This is analogous to, say, HTTPS in the early days of the internet. We needed a secure mechanism for e-commerce in the late and mid-90s, and HTTPS emerged as the dominant solution. We think that the same problem fundamentally exists within blockchain today because we need to extend all of the economic securities around direct interaction into these edge-connected devices. Or why are we spending all of this extra time, resource, and effort to use a blockchain if we're going to undermine its benefit as soon as we try to have end users interface with it? The technical challenges, obviously the first three we've talked about, and there's, like I said, many different solutions, be it sharding, plasma, microfiber chains, micro-communication channels. All of these are very promising and emerging technologies. The other things that we need to really figure out are, of course, the database size and the secure edge. So the final point that I'll make is that within that database size, as it continues to grow, we're going to have a problem that it becomes progressively more expensive to store this information. We need to find a mechanism to incentivize nodes to actually host database, the blockchain database. MIMIR has been building our technology around the idea that we would facilitate this kind of an interaction and that it would be to the benefit of the network if we did so. The idea is that, as we saw on the previous slide, there are 30,000 nodes that exist in the world, and there are an immense number of people who want the information that these 30,000 nodes possess. What we've been building is a system that stands in the middle, much like Uber connects you with someone who's willing to give you a ride. MIMIR is building a system that will allow you to be connected with someone who possesses blockchain data and can distribute it back out to these devices and use proof of stake to hold them responsible for what they've said and provide economic security. The solutions are, of course, not, many of the solutions that were on the previous slide are not going to solve all of the problems. It's going to take a mishmash of many different technologies, and if we're all trying to actually build these technologies, we need to understand what the fundamental problems are if we're going to build products that are going to scale and get into the technology that will redefine tomorrow and truly be disruptive. Thank you for taking time to listen to me speak. I hope that I at least brought some things to your mind, things that need to be thought about. Once again, I work with MIMIR Blockchain Solutions. You can find our technology and what we're working on at mimirblockchain.solutions. Thank you very much.